trig lesson we had. We said the x always corresponded to cosine and the y corresponded to sine. Again, assuming that our angle, remember our angle that we have in these problems needs to be this angle here. And remember that symbol, I called it theta. It just means angle. So if theta is 30 degrees, the 30 is going to go in here for theta. Okay? The 30 will go in here for theta. But they're different answers because sine and cosine functions are different. Okay? So this is going to be our general rule. If you have something that's fired at an angle, like so. So imagine you're at one end of a football field and you decide to punt the ball and it goes like 40 yards, but it gets lifted off at an angle of 30 degrees. You need to find the angle's components. So here's the velocity of the object initially. The board is way off. I'm going to go over here. Sorry. We'll do it over here. All right. Here's the velocity of the object initially. Okay? It's the velocity at an angle. Say the angle is, again, let's say it's 30 degrees. This velocity has two components to it. It's got a vertical component, VIY. It's got a horizontal component, Vx. Remember, this would normally be Vix, but there's no difference in the x direction between initial and final. Remember in the x direction, go back over here. What's the acceleration always in the x?
0.
So since there's no acceleration in the x, we don't have to call this Vix and Vyx because initial and final are the same. But in the y direction, the velocity changes because acceleration affects the object. So we're going to think of this problem as if it's two completely separate entities. Okay, we're going to work on this problem as if it's going up and coming back down, and as if it's going just to the right. Okay, two completely separate entities. So let's take a look at our first example here. I know, I knew this in my last one, I forgot about it, that word.
Whoa.
You put a circle around the text?
No way. I don't believe it.
Crazy, right? Okay, anyway.
Technology.
Alright, so Tom Cruise strikes again in a new action movie. Here's the last one, I thought we'd use him again. Now, he has to leap from the top of one building to another building that is 4 meters away. So he's running from rooftop to rooftop. After getting a running start, he jumps at an angle of 15 degrees with respect to the flat roof while traveling at a speed of 5 meters per second. I'll draw a diagram in a second. Will he make it to the other roof, which is 2.5 meters lower than the roof he's jumping from? So a diagram helps, right?
Well, he's not.
Draw a diagram. Okay, so far?
Okay.
How far apart are these different buildings? 4 meters. So I'm going to draw 4 between them. How much lower is the one building than the other?
2.5.
Yeah, 2.5. So let's draw a little vector or a little segment here that says 2.5. Okay? When we put it in y direction, what are we going to have it as? What did you say?
Negative 2.5.
Negative. Remember that. Good.
Thank you. That's okay.
Now, Tom Cruise runs. He jumps at an angle, and we hope that he makes it. Or we hope that he doesn't make it, depending if we like it or not. Now, that angle that he jumps at is given as 15 degrees. Okay? He has an initial speed of 5 meters per second. So if I were to actually draw this diagram now with just a model, remember we talked about modeling, here's what I see. I see an object launched like this with a velocity of 5 meters per second at an angle of 15 degrees. I know that from the start to the finish, my y is going to be negative 2.5, my delta. And I know from start to finish, my delta x is going to be 4. Okay, let's put units of meters, please. Say again?
I know where you're getting the numbers from, but are you
No, not right now. The angle 15 degrees is just the angle that he launches with. And then he's going to come back down. The 2.5 is the overall change in height. He's going to go up to here, but he's going to come back down. And this change in height right here, Molly, between the first dot and the second one, the vertical change is negative 2.5. That's this gap right there.
The initial velocity is 5 meters, I guess.
We don't know. No, it's not. It's at an angle there. We have to break it into its horizontal and its vertical. Okay? All right, now, for this problem, I want to start with an x and y Setup. Before I break up the velocity of the components, let's write the stuff that we know. Tell me some things that I know from this problem. Look at it.
X equals 5 times cruise.
What is it?
4.
And y is? Okay, so far so good? Now, the question is this, guys. The question is this. For this problem, we want to make sure that he actually lands at a certain distance, right? So, we're trying to figure out if he's going to actually jump to the other roof. So we want to see, like, what is his actual delta y going to be? Is he going to fall through here? Is he going to make it across? What's going to happen for this problem, right? Is that what we're looking for?
Yeah.
Okay. What else do I know? What else do I know? Huh?
The acceleration. So x is 0 and y is -9 when you want.
Okay. So far, so good. What else?
Why is the original acceleration? I mean, why is the x acceleration 0? This is just not accelerating.
Remember, there's nothing that's like really propelling him forward after he leaps, right?
Okay.
So his velocity is not going to change that way. But the Earth is pulling him down, so his velocity will change in the vertical direction. Initial velocity, that's what we have to work on now. It's not. That's the key. Remember what we wrote, guys. Vx is really now going to be V cosine theta. VIY is going to be V sine theta. And so you have to write these out now. So,
Oh wait, so VIY isn't going to be 0 anymore, right?
it's not going to be good. VIY is not 0. Because now Tom Cruise has jumped upward in addition to jumping out. So he has a vertical component of velocity now. Because he jumped up and out. He didn't just jump right off the cliff or run off the cliff anymore. So, in the x direction, let's put this down. 5. Focus, gentlemen. That's going to be his Vx right there. Remember, the velocity he started with, but at an angle. VIY is the same thing, but instead of cosine, okay? That's the key for this problem here. We are no longer looking at objects fired only horizontally or only vertically. We now have to think about the fact that we do have some components. Here's the question though. I almost have too much information in this problem. Because notice here, time is unknown, and time is unknown over here, both. But if I find time, that's not going to help me. What does the problem actually say again? Will he make it to the other roof? Will he make it? Will he make it? So what do we have to find? Stash?
Wouldn't you not be able to use both values, x and y, because you're not sure if they match?
So, answer the question I asked.
So you can only either look for x or for y.
So which one in this case would make sense?
The x.
Yeah, so again, guys, we want to know if he's going to make the 4-meter gap, right? Isn't that what the gap is? So what we should really do is put a question mark over here now. And this is what a lot of you struggle with on your test. Put a question mark here. Because we want to know what is his gap going to be. So for example, if x turns out to be 5, he clears it by a foot or a meter, right? But what if x turns out to be 3? What does he do? He falls. He comes up short. Again, the gap is 4 meters. If we solve for x and get 3, it means he's a meter short of the next roof. If we solve for x and we get 5, he cleared it by a foot or a meter, geez. Okay? So we need to find x. It's very misleading, this problem, because you want to say x is 4, but x is unknown. The gap is 4. We need to see what he actually covers. Okay? All right, so let's do this. We don't know x. We don't know time. So I can't look at the x direction just yet. What direction should I look at? The y, so we know the direction. So looking at the y direction. Looking at the y direction. Somebody give me some advice here. I'm not going to do the problem for you. Let's go. Luis, be careful, because VI is not 0 anymore. When VI is 0, you can use that one. But before that, Luis, there was another formula we used. A little louder next time, but I heard you. A little louder, please. So VIYT plus 1/2 AT squared. Now, the problem here is this. Notice, what are you trying to solve for? Isn't it in 2 spots now? And VIY is not going to drop off anymore. So this is going to be what kind of an equation? Quadratic. Oh, not the quadratic. All right. Y is negative, what is it, negative 2.5?
Yeah.
Somebody tell me, 5 times sine 15, what do you get? Make sure you're in degree mode and not radian mode. 5 times sine 15 is not 75. 5 times 15 is 75. You're going to do 5 sine 15, huh? 1.29? Degree mode, not radian mode. Now, guys, come on, focus. Look up here, stop looking at each other. 1/2 of negative 9.81. It occurs a lot. Did you get familiar with the number? Half of 9.81 is 4.905. Just because this number occurs a lot, please get familiar with it, okay? Now, you can clearly see we have a quadratic. We need to put in the correct order. Let's move the 2.5 over here. What does it become? What does it become? Good. We're going to have a positive 2.5 at the end. Again, because to get rid of this negative, we need to add it to the end of both sides. Now I'm going to switch the order of these two so that it's in standard form. So I'm going to write negative 4.905 t squared plus 1.29 t, and now I have a quadratic. Remember we did this, guys. We did this already. Okay? This is A, this is B, this is C. Okay? I'll provide you with the quadratic formula on your test. You don't have to memorize it right now. In that, you're going to need to memorize it, so if you want to start doing it now, you might as well. Remember, your test is through horizontal. This is the new stuff on the next test. Okay, but it's important that you understand it still. We'll just ignore it.
On
Next.
the topic of the test.
Quick, Max, because we're in the middle of a problem right now. This is
The
rough.
triangle things?
No.
The cosine
No.
stuff?
Now, it's not on. T equals, whoops, negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's go ahead and plug numbers in. T equals, negative b is negative 1.29 plus or minus the square root. B squared is going to be 1.29 squared. Minus 4 times A, which is negative 4.905, times C, which is 2.5, all over 2A.
Bless you.
Thank you.
God,
This is
God
going to get a
bless
little bit
And your
messy.
family.
you. God bless you, Jesse. God bless you.
So I'm going to do under the radical first, please. So type 1.29 squared minus parentheses 4 times negative 4.905 times 2.5. Okay? Let me show you on the, I have the virtual calculator, I forgot. I'll show you there so you can see what I'm doing. So, we have 1.29 squared. This is under the radical. We're doing what's called the radicand. Minus, parentheses, 4 times negative 4.905 times 0.5, close parentheses. Everybody clear?
Yeah.
Hit enter. Now we need the square root of that, right?
Yeah.
It's a radical. Second, square root. Second, answer. See down here? It pulls up the previous answer.
No.
So if you have an answer on the last part, you press second square root, press second hit answer. It'll bring it up. 7.12. So I've got t equals negative 1.29 plus or minus 7.12 over negative 9.81. That's what you get when you multiply these two. Now what should I do? Who remembers? Once I get to this stage. There was a step I told you to write down in your notes. At this point you need to do something.
You go off from 2.
Very good, Jeff. Well done. Break it into its two answers.
Oh, right.
Negative 1.29 plus, and then negative 1.29 minus. Now, let me just discuss real quick. Take a look. Watch this. Before I can do the answer, just watch, please. Don't do it. The numerator in the first part is going to become positive, isn't it? 7.12 is bigger than 1.29. It's going to be a positive over a negative. So what kind of an answer am I going to get there? So do I care about that answer? I really don't. You see what I'm saying? Save yourself time. It's going to become negative. The time's got to be positive here. So do the bottom one. Negative 1.29 minus 7.12. Enter. That's negative 8.41 divided by negative 9.81. 0.857. We agree or disagree? Did you all check, I hope? Again, this is from this answer right here. Positive 0.857 seconds. Now my final step is to take the time from the y direction and put it where? Go back to the beginning of the problem. What are we trying to find? Good, Molly. Thank you. One person is listening. The x. Guys, come on. We got to know this stuff. We said it a minute ago. We're trying to find x. So we found the time over here. We got 0.857. We can plug it in right here now. And now we can find the x. Now remember, Vx is not 5. We got to do 5 cosine 15. Let me make sure I'm in degree mode. I am. So this is going to become right here 4.83. This quantity is 4.83. So I've got Vx equals x over t. Take the t, move it up. Get rid of it. We get x is equal to t times the Vx. The time is 0.857. Vx turns out to be 4.83 equaling x. So 4.83 times 0.857 gives us a number of 4.13 meters. Does Tom Cruise survive?
Yeah.
He does, because the gap was how much? So he just makes it by 0.13 meters.
Tom.
And he just makes it. One other thing before we end today.
I was going to say that earlier. 3.5. Since it's, if it was at the same website, just the same.
No. We're looking at the 4. We're not comparing it to the 2.5. That's the distance he's going to travel downward. I'll explain more in a second.
But technically, he wouldn't actually have to jump 4.13 meters. It's farther.
Well, guys, hold on one second, because we're running out of time. I was. Your next problem set is not due not this Tuesday, but the next Tuesday.
Oh, thank you.
Now, listen carefully to me. I'm telling you this, it might help you. I recommend you listen. These problems, a lot of them are on the stuff that's on your test. So this weekend, if you want something to study from for your test, it might be useful to look at least page 102, 104. Some of these are at angles. If you see an angle of like 20 degrees, then it's on the next test. So maybe don't do that one just yet if you don't want to. But a lot of these problems, it's going to say the object is fired horizontally. Okay? Now, besides doing this over the weekend, the solutions to the first problem set are on Moodle. These are my handwritten solutions for that whole first problem set. They're not back to you yet. So I put this on Moodle. So please go ahead and take a look. Look on Moodle, you'll see under problem sets, it's page 44, number 6. Take a look at the work I did. This will help you for your test. Is that clear? Okay? Study your notes, study these problems, study any homework problems. This is on Moodle, under problem sets.